All right, so we're following up with the panel, so I would ask the panelists, this is a self-moderated panel. I would like the panelists to come in and take their places here. And while they do that, let me try to perhaps explain a little bit. Some groups are so much into the specific analytics that it's hard to portray what we're doing. And what I would say is we're dealing with the VA, we're dealing with institutions that definitely need to keep their data inside their computational environments. So centralizing the data is not an option for many of our analysis. And neither is an option to send our data to the VA, for example, because that will not be scalable. So instead, we worked on the algorithms that send the analysis to the data and can put them together again as if they were all in the same place. So there's no magic, but there's a lot of manipulation of functions in the logistic regression model and in other models. So that's the beauty of the approach, which of course requires communication among the sites at every iteration and so on. Another difference that we noted is some systems are fine once they approve what that computation is. Some other systems prefer to see the results before they are sent back. And in our case, the results are coefficients and p-values and other things. So as we get used and we see that there is very little risk of re-identifying someone by the coefficients that get returned from each site, then I think this will have a larger uptake, perhaps in other networks as well. So I am serious. Please do take your seats. Otherwise, I'll have to stop talking. So please.
We're just on links.
Okay, yeah. So NLP is another difficult area because every review has shown that there is no current way of de-identifying clinical notes. There is always something left. And for that purpose, we will think in the future of this distributed analytics as well, but we also thought of a system where you could submit your notes, the NLP would be done, and the structured data would be returned to the sites. So we're, in that case, also operating in a potentially centralized way for the notes only. So in the self-moderated panel, we have NLP experts from different systems, and they will talk about the plans. They will talk about what they have done in their own sites, but also on the plans moving forward. So I will ask you to introduce yourselves and again self-moderate. Who's running the slides? Everyone comes and manages them. So we are with the set from Chunan here.
Yeah, my name is Chunan. I'm part of the faculty member of the DBFI.
Michael Matheny at the Tennessee Valley VA in Nashville and Vanderbilt University.
Hua Xu from the University of Texas Health Science Center in Houston, School of Biomedical Informatics.
I'm Scott Duvall from the Department of Veterans Affairs and the University of Utah.
So
I think I'm up first, right?
Yeah, you're the first.
There we go. Speaking of magic, so I was asked to introduce the problem. And I like that because we've got a lot of good solutions that we're going to present to you. I want to put into your minds something that will give us job security so that you know that we're working on something that's tough, or at least that I'm going to make you think is tough. It's something that is challenging, but it's something that, that we and many of us here like very much. So you may have heard this quote before. The nice thing about standards is that there's so many to choose from. Furthermore, if you do not like any of them, you can just wait for next year's model. Now, this has been attributed, or at least parts of it has been attributed to both Andrew Tannenbaum and Grace Hopper, who were pioneers in computing. So this is what we were getting in the 60s and 70s. Now, what I want to do is put a little bit of a different spin on it and say the great thing about natural language processing tools is that there's so many to choose from. Furthermore, if you don't like what's available now, you just have to wait till next year, till the new models are out. One of the problems with natural language processing, and I'll go through some of the challenges with the actual task, but with the development, one of the challenges is that because we see these things as different problems, because we see different institutions having different ways of solving it, sometimes we're reinventing the wheel over and over again. And so this collaboration is supposed to help and coordinate the development of these tools. There are two different traditional approaches, both that lend themselves to reinventing the wheel. The first one is a targeted approach. Because we're in the Department of Veterans Affairs, we like to keep with, the military theme and other things. We call this the rifle approach. And the rifle approach means that you're solving one particular problem, but you're solving it well. There's a particular variable that you're after, or there's a particular set of variables that you're after, and you're going to tackle this in many different ways across all of the notes that might be in the patient population that you want to study. The second approach is the shotgun approach, and the shotgun approach says, we're going to try and capture everything in the note. And there's several systems that are available both as open source and commercial that do both rifle and shotgun approaches. There are pros and cons to each. And so each time some folks like us use one of these systems, we think, I can do better. So I'm going to invent a new system that will do very similar things, but do it better. And the coordination and the approach for taking some of these tools and customizing them for other environments instead of reinventing the wheel is really what we're going to focus on as the solution. The second part, and a reason why we have a lot of reinventing the wheel, is you may have heard if you've seen one, you've seen them all. This is if you've seen one, you've seen one. And I did a quick Google search, and that phrase itself fits in with medical records a lot. But it also fits in with a lot of other concepts. So when we see things like a good system like MetaMap that was developed by the National Library of Medicine and trained on PubMed and the biomedical literature there. When we see something like CTAKES, which is also open source and trained on clinical data, and then when we try and apply those to our data sources, we go from what they claim they get on their data sets to sometimes 50%, sometimes 60%. Anyway, just things that aren't acceptable as we transition. So everybody has their own data. The number of notes, the number of different types of data, the number of formats, the number of authors across time. What's the best way then to take something developed at Site A that works really well and move it over to have it work well in Site B? The next piece that I'll talk about is some of the challenges with both privacy and technology. So this right here is a document released from the FBI after 25 years of trying to get the John Lennon file released. It was finally released, and this is what it looked like. And so this is what de-identification can look like in clinical notes. We'd be happy to redact all of the words and then give you the document. So as Lucilla mentioned, there are some privacy concerns that de-identification isn't a science that we're able to solve. And so having the business associate agreements or the other things to make things work centrally is one option that we're moving forward with. And then that second option is to be able to take individual systems and have them run independent within the environment and then just release the output, which then wouldn't have identifiable information in it. The second piece is technology. So it's not trivial to move this much data back and forth. The VA generates more than 1 million clinical notes every single day. Most natural language processing systems that we've tested just on a normal setup cannot handle that throughput in a single day. It can't catch up to the amount of documents that are actually being created. So just think, as we're trying to pipe all this data around and trying to force it through these systems, that's another challenge that we're going to address here in pSCANNER. Lastly, the scalability. As I mentioned, some of these systems can't process notes as fast as we're creating them. And so you'll see a couple of solutions that we have for scalability in terms of a centralized place. In VA, we've attacked this by building a cluster of natural language processing systems. We've used standards that are available out there, standard frameworks that allow us to take some of these systems apart and then multiply the computing resources put towards them. So I hope that gives you an idea of why natural language processing is a little bit of a challenging problem, and then I'll turn it to my colleagues to present the solutions.
Thanks, Scott. Really nicely lay out the problems and trying to figure out how to move. So actually, I'm going to focus on particular problem Scott just mentioned, the transportability of NLP systems. And when you develop NLP system, it's not done yet. When you're trying to move it from one type of keynotes to another type of keynotes, or from one institution to another one, or even from one application to another, we often found it takes tremendous effort actually trying to further customize the system to reach the performance you want. For example, we take a CTEX smoking module. When we looked at the paper on the male clinical data, they reached over 90% F scores. But when we run that by default on the Vanderbilt data, it's actually dropped to like 56% of the F scores. So it took a lot for our effort trying to retrain the model, re-specify the rules. It's actually kind of easy for NLP team, because we may spend like 2 weeks of my programmer's time to tweak the system and improve it. But for any end user who don't have much NLP experience, what can they do? So we really think there's a need a solution actually trying to help end users to customize NLP modules for their local data. And today, all I'm going to show a few slides is about a system we recently about to release. It's called a CLAMP, which is, you can think of it as another type of CTEX meta general concept extraction system. And we shamelessly claim it has high performance. We've been participating in a lot of clinical NLP challenges and ranked pretty high for different methods. And we're trying to build those proven methods to this system. But most importantly, what I want to talk about is the high customizability of this system. We're trying to develop a user-friendly GUIs for end users to re-annotate the data, retrain the model, as well as add the rules on the top of existing NLP systems. So this is how we do this. For example, this is just one screenshot showing the interface. We have all the different modules. If you're familiar with NLP pipelines, tokenizer, sentence boundary detection, POS tagger. So all over here, you can drag drop our pre-developed modules over here to form the pipeline. And more important is we actually allow you to customize those pipelines, each component. For example, you have a dictionary. We can easily to replace all the terms in the dictionary using our system to add your own terms. And this is showing annotation, because a lot of the time, if it's a machine learning-based module, when we're trying to run our system, we often notice we have to re-annotate, retrain the module. How we can do this? So we actually implement the annotation interface in this system. Here, you can highlight text and select what type of entity it is. And once you annotate this, you don't have to be an expert of machine learning. You can just click the button, and we're going to actually retrain the system and allow you to specify the feature. And once you have retrained the system, it predicts on the data set. And we also allow you to compare what's the system's prediction versus what's the gold standard. And further look at errors for the machine learning module. And after that, we also notice a lot of time machine learning makes errors, which kind of stupid errors, and any kind of human expert look at the result can easily add a rule on the top of it to fix it. So that's why we actually have a rule engine module trying to, on the top of machine learning modules, you can specify a rule to further correct those errors. For example, in this example, we're actually showing this term, I don't know exactly how to pronounce this, but test-lucent, which labeled as a test in our output. But it turns out it's actually a medication, because it's very obvious it's in the medication section, right? So what we did is you can highlight term, and we can have a simple interface allow you say, for this token, it happens in the medication section, label it as a treatment, as a drug. And all this actually can further be modified in the rule engine, which is a file. You can, if you know, the syntax is actually quite understandable, and you can actually modify here as well if you're more familiar with those kind of text interfaces. So this whole simple kind of feature can address a question like, I run the ctext, but for my particular problem, I still see a lot of errors. I want to fix it. And you can use this simply add some rules to further build a post-processing component for the ctext NLP system. So now we are actually actively finishing 2 wrappers for ctext and metamap. So we convert ctext metamap output to our format, so you can load it into our system and look at their output, trying to add rules on the top of it. So basically that's it. The system is going to be available in about a month, and we're finalizing the license stuff and documentations, and if anyone interested can contact me. Thanks.
Thank you. And so what I'll be talking is, it fits nicely in line with the other 2 presenters. And so when you're trying to do these NLP pipelines, just as Scott mentioned, when you build them in one place and then you have to apply them to the other, you have to still validate it. In most cases, there's no way to get around doing an annotation in your target environment and then retesting the system on the target environment so you can get an idea of the performance characteristics in that environment. Annotation is very expensive, and so some of the work that we've been doing is trying to help annotators annotate more quickly at a cheaper cost with a larger volume to do assisted annotation. And then those assisted annotations can then be used in exactly in the type of system that Hua is talking about, where you can use those annotations, retrain your tool, and move forward. And so, in assisted online learning or assisted annotation, essentially you have a set of documents, you have a human annotator, there's no pre-annotation, they do the annotations, and there's a machine learning system in the background that essentially is a lot like an NLP system itself. It's just not trained, and so it learns from the annotations that you're building, builds an algorithm, and then pre-annotates the next set of documents before the user then sees them. Then you make the corrections, fix things that are wrong, and then that iteratively continues, where you gradually train the tool to basically represent yourself electronically so that it can do the pre-annotations without much of your intervention. And so I just have a few slides, but we've embedded this sort of assisted annotation system within eHost, which was developed through some VA HSR&D funding. This represents sort of a concept level extraction, where you basically have certain concepts you're interested in, you annotate it, and then it sort of trains those. The thing that we're working on at this point is actually doing context, so where you can assign, if it's a no dehydration or no shortness of breath uncertainty and time relationships, and then it uses a machine learning algorithm in the background to actually learn your attributes around your concept tagging, so that it can reproduce basically the attribute tagging as well as the concept tagging. Just to give you an example of why this is useful, so if you look at sort of how much you can annotate per kilobyte of text, you can see that when you have an assisted annotation system, you start out at 20 seconds per kilobyte of text, and then over time, as the tool learns and gets better at doing things, you end up with a reduction almost to 25% of the time that it took originally to do these annotations. So you can deploy this in each of your target environments, get an annotation sample, and then evaluate and retrain your NLP system using the other tools that have been mentioned. This is another example of sort of annotations per minute, and so you can see in a comparison with a manual reviewer set of folks that the speed of annotation continues to rise. We didn't really hit steady state at our study, but sort of helps reduce the cost of doing those validation pieces. And lastly, we've been trying to incorporate active learning. So there's one way where you select documents randomly and then annotate them in order to assist and be more rapid in your training of the algorithm to do the annotation. But you can also select documents that are not similar to the previous documents you've already selected, so that you can essentially see new terms and train the edges of your algorithm more quickly. There's uncertainty sampling. There are other methods that can do that. And even though these two curves, which is comparing random and uncertainty sampling, look very similar, essentially if you look in where you're getting into your really higher accuracy of pre-annotation, it can reduce the time by half that it takes to get to a target accuracy rate by batches by doing an informed selection of the documents that your annotators are seeing. So this is one of the tools that we might be able to use in this as we're doing the validations of the algorithms in different pieces, in different institutions. Thank you. That's not me.
Questions from remote side?
Yeah, I don't know. Is there someone calling in?
Yes, don't worry about it. We'll take care of it up here.
Oh. Thank you.
The next panel.
Okay, so this is Chin-Man. Thank you for the calling from the outside. Well, yes, so I try to explain our solution to a problem where we need to deal with in such a distributed environment in pSCANNER. And our solution, we still follow our basic principle, which is to encourage people to share their resources, including both data and software. So we follow that principle and propose our solution, which, so first and the most basic requirement for sharing of the software is to make sure that all of the software output in a standard format. And specifically for pSCANNER, we have, with the support of our subject matter experts, we deal with three use case conditions and diseases, which is the KD and the congestive heart failure and weight management and obesity. And for these three diseases conditions, we have identified about 180 data elements that is common to the study of these three conditions. And we specifically identify their corresponding codes in SNOMED CT and LOINX and RexNOM, which is the standard codes for drug and the medication. And these are widely used for studies for these conditions. And we would like to make sure that they will be ready to be inserted to OMAP CDN data and become part of the structured data. And we're also considering the provenance problem, which is to make sure that the data inserted to the structured data, we know where these data comes from, is from which node, from an NLP tool, and maybe attached with a certainty score, or showing the modality of how the physician, when they report these conditions, their certainty in the nodes, and also the confidence score from the NLP tool itself, so that when researchers actually use the data from the restricted result, they can deal with that. And we want to also make sure that all of the tools shared in pSCANNER can maybe follow this standard, so we can actually put these software to work together. So the next solution we would like to propose is to build one more layer. Where is the pointer? Yeah, one more layer. Here is from all the nodes. We, of course, do some pre-processing and then feed it into all kinds of useful NLP tools, shotguns which is the other shotgun approach, as well as the more targeted approach that all included. And then we put one more layer, which is an ensemble layer, which will put together all of these tools and to synergize their strengths together. An ensemble approach is a very useful and well-studied approach to integrate a large number of tools together. So you may have tools that develop in different sites and maybe more suitable for the certain sites. And when you put all of them together, you could take advantage of their strengths and then make them, when they integrated together, will work better than one of them. So this approach has been shown to be very powerful in a lot of competitions, such as Netflix. They challenged the research community for $1 million to develop a new recommender system to recommend videos for their viewers. And eventually, scientists put together 100 different recommenders together using an ensemble approach to finally beat the system that Netflix claimed to be the best that they developed of their own as a proprietary system. And finally, an ensemble of such a huge, giant ensemble defeat that. And then during the process, a lot of the approach has been, and the theoretical analysis has been developed for these ensembles. So currently we have about 9 different ensemble approaches put together in this ensemble layer in our pipeline of an NLP system. And the basic one can be as simple as just to put a union, which is that we just output everything that the set of our tools give us. So say you have a tool that tailored to one site that is good at certain set of vocabulary, certain way of the expression from the physicians in some medical center. And when you put all of them together, the system certainly now will have a much larger vocabulary than their own. So in that way, and we actually put a little test by combining C-text and meta map together, and the union actually always constantly outperform when we apply each of them alone. So this shows that even a very simple ensemble approach can go very far to take you. And then you will be able to allow different teams to develop their system, and then we have this environment to like integrate their strengths together. And then, of course, we need to consider the security and the privacy protection into account. And so we have already have the iDASH environment, which we can build on for NLP processing. And in particular, we are working on wrapping these NLP tools with Docker. And this will allow the software to be shipped in different environments and still can be interoperable in different environments. So with this environment and an ensemble approach, we think we will provide a friendly environment for people to share their NLP software as well as the research data. Yeah, thank you.